Hi, I am Abhraneel. I am a PhD student at Northwestern, and I'm going to be talking about our paper, Milliways, Taming Multiverses Through Principled Evaluation of Data Analysis Paths. This is work done with my co-authors Kyle Hwang, Jessica Hullman, and Matt Kay. Let us assume that a researcher is trying to answer a research question on the effect of social media usage on depression. They conducted a survey and collected some data. In this survey, there was more than one question which can be used to indicate a participant's social media usage. For instance, one question asked participants how many hours do they spend on social media per day. Another asked them to self-report using a Likert scale whether they consider themselves a low or heavy user. In this fictional example, 4 such measures of social media usage were collected. While some of these measures may be more strongly correlated with social media usage, the researcher implementing the analysis is unaware of this. Moreover, there may be outliers or extreme values in these measures. There are 3 other variables recorded in the survey which are known to influence both social media usage and depression. But the researcher is unclear on the directionality of these effects. We'll use this study as a running example throughout the presentation. The data analysis process for the study described previously will comprise of several steps, such as the choice of predictor, choice of covariates, and outlier removal, etc. For each of these steps, the researcher is faced with more than one alternative for accomplishing these steps. In a traditional analysis, the researcher might have to, for each of these steps, make a decision and implement the analysis which results from these choices and report only this one analysis path. Unlike a traditional analysis, in a multiverse analysis, the researcher implements and reports each of these unique analysis paths obtained from taking the combination of every choice for every decision in the analysis process. Libraries such as the Multiverse R library, which my collaborators and I have developed, and BOBA, which is developed by the folks at Jeff Heer's lab, have made implementing such multiverse-style analysis easier. But taking a step back, let us ask, why should we perform such analysis? Multiverse analysis was proposed as a way to increase transparency in the data analysis process. If for a particular research question and dataset, the best way to analyze the data is unclear, a multiverse analysis is useful as it surfaces uncertainty in the results due to arbitrary but equally justifiable choices in the data analysis process. I particularly wanted to emphasize 2 things here. First, the goal is to understand the variability in the results, and second, how this variability relates to arbitrary but defensible choices in the data analysis. Let us first focus on the statement that says alternatives need to be equally justifiable or defensible. What would happen if we were to include an unjustifiable alternative? Well, due to combinatorial explosion, the size of a multiverse quickly increases exponentially as you add more decisions and choices for these decisions. Taking the abstract multiverse representation from earlier, if one of the choices for the final decision was actually not justifiable, we end up with a third of our analysis paths as unjustifiable. Say, actually 2 of the choices for this decision can be considered unjustifiable. Now we have more unjustifiable analysis paths in our multiverse than justifiable analysis. As prior work puts it, including unjustifiable alternatives can drown out reasonable results in a sea of unjustified alternatives. As such, we propose that we need a principled approach to validation of multiverse analysis. In our paper, we argue that the principled validation of the construction of multiverse analysis involves using domain knowledge and statistical expertise to construct arguments in favor of or against certain choices in the multiverse. We are a proponent of this domain knowledge-based approach because there are limitations to adopting purely metric-based approaches. We discuss this in more details in the paper. Prior work by Hall et al. Proposed a taxonomy of 4 multiverse analysis tasks which can be used to understand a constructed multiverse analysis. The first task is the composition task, which are concerned with understanding the steps in the data analysis process, what decisions and choices for each decision points were declared. Outcome tasks involve assessing the overall variability of an outcome across the set of multiverse specifications. Connect tasks include determining whether certain analytical choices lead to outcomes differing across analysis specifications. And validate tasks focus on assessing the validity of the specified multiverse analysis. Thus, a principled validation involves performing all of these tasks, which culminates in the validation step. When we outlined why we should conduct multiverse analysis, we also highlighted that such analysis surfaces the uncertainty or variability in the results. Following on from prior work, in our paper, we adopt the notion that the results of a multiverse analysis comprise of two qualitatively different types of uncertainty. The first is probabilistic uncertainty, the uncertainty in estimating a quantity whose true value is unknown. A common example would be a regression coefficient or the distribution of a random variable. We can visualize such uncertainty using representations such as density plots or mean and 95% confidence interval. The second type of uncertainty that arises in multiverse analysis is possibilistic uncertainty, the uncertainty due to variation in the decisions involved. Thus, we identify a fifth task, interpret, which involves interpreting the results of a multiverse analysis whilst distinguishing the qualitatively different forms of uncertainty that arise in such analysis. However, in the interest of time, I will not discuss in detail about the interpretation task in this presentation. Please refer to the paper for more details. Thus, the principal evaluation of multiverse analysis consists of these 5 steps. Milliways is an interactive visualization system which allows a reader unfamiliar with the implementation of the multiverse analysis to perform the tasks identified previously. The Milliways interface consists of 4 panels. The code panel, which shows the R code used to implement the analysis. The data panel provides an overview of each column in the dataset and provides supporting information to the code panel. The specification panel reveals the composition of each analysis path, also referred to as a universe, in the multiverse. The labels at the top correspond to the decisions that an analyst has declared, also known as parameters, and the sublabels correspond to the choices available for that decision, which are also known as options. In this case, the first row corresponds to the analysis path obtained from choosing the first option for the outlier exclusion decision, the fourth option for the SM predictor decision, and so on. We use this representation because it provides a flexible and scalable layout of representing the tree of decisions that comprises a multiverse analysis. And finally, the outcome panel consists of a histogram of the point estimates across all universes. In addition, we present the results from each universe using a consonance curve. The consonance curve represents the two-sided p-value function. In other words, the probability of the data given that the null hypothesis is X. In most cases, the p-value being referred to is the null p-value, which corresponds to the null hypothesis of no effect. This is given by the value at x equals 0. However, the p-value is defined for every value of x and is represented by this curve. Moreover, horizontal slices through the consonance curve are confidence intervals at 1 minus alpha. So this is a 50% confidence interval for this parameter, and this is a 95% confidence interval for the same parameter. We use consonance curves because they can be more easily adapted to visualize possibilistic uncertainty, which was one of the goals of this work. More details about consonance curves and how to interpret them can be found in the paper. To demonstrate how Milliways may be used, we will be returning to the fictional simulated dataset of social media usage on depression. To understand the composition of the multiverse, we start at the code panel. This reveals that the multiverse consists of 5 parameters. We can click on the parameter names to expand and view how the options are specified for each of these parameters. Here, the parameters are related to outlier exclusion, choice of predictor, and including or not including the variables age, sibling, and activity as covariates. Next, we see that the outcome in this analysis is the regression coefficient of social media usage on depression. To perform the outcome tasks, we can more closely inspect the outcome panel. The histogram at the top highlights how both positive and negative values are possible. This extent of variation in the outcome implies possible effects in different directions. This raises the question, do certain outcome values depend on certain choices in the analysis process? In large multiverses where all the outcomes cannot fit into a single view, it might first be helpful to zoom out by clicking on the zoom out toggle. In the zoomed out view, we observe that all the universes which include activity as a covariate are towards the top. As the rows are sorted in ascending order based on the mean of the coefficient, this implies that if activity is included as a covariate in the regression model, the coefficients are going to be smaller than when they are not included. Thus, outcome is sensitive to the decision to include or not include activity as a covariate. Now, what I did not reveal previously was that activity was a collider in this fictional dataset by construction. As such, the correct choice would be to not include it as a covariate in the regression model. By surfacing that the variation in outcomes is due to the decision concerning including activity as a covariate and revealing the composition of the multiverse within the same interface, Milliways allows users to leverage their domain knowledge to reason about the sources of variability in the outcome and validate the multiverse. In the paper, we discuss in more details on how more complex multiverse analysis tasks can be performed using the Milliways interface. If we cannot make an argument for excluding any other choices declared in the multiverse, we can then aggregate the results over all the remaining specifications. Aggregation collapses the specifications into a single row and provides us with a composite representation of both probabilistic and possibilistic uncertainty. This representation is a variant of p-boxes that can be used to interpret the overall variability in the result. In the interest of time, I will not discuss how to interpret p-boxes. Please refer to the paper for more details. To evaluate the Milliways interface, we conducted a user study with 5 participants. Here, we briefly discuss some findings from our usability study. Participants found the code panel to be intuitive and helpful for understanding the decisions and choices declared in the multiverse. One caveat here is that all of our participants were proficient in R. A future design opportunity may be to consider more abstract, language-agnostic representations of the multiverse code, which still reveals enough details about the composition. Participants assessed whether an outcome is sensitive or not, primarily based on the direction of effects. If the multiverse results in outcomes which span both positive and negative values, participants found the direction of effects to be unclear and took this as a potential indicator for outcome sensitivity. To identify the sources of sensitivity, participants engaged in a visual search for pattern in the specification panel. We also observed that participants often discuss the reasonableness or justifiability of the choices included in the multiverse, suggesting that Milliways provided enough information to reflect on the validity of the multiverse construction. As all our participants were experienced researchers, they approached this validation step based on their respective principles of statistical modeling. Finally, we used p-boxes to represent uncertainty in the multiverse results. Responses from 2 participants revealed that they may be adopting the desired possibilistic interpretation using p-boxes. However, we need a more focused, large-scale experiment to reveal whether uncertainty representations such as p-boxes are interpreted as intended. Thank you.